Welcome back. In the last lecture session, I have introduced you to the concept of exceptions. And so we have to handle the exception. If you leave an exception unhandled, then it is not a case of a professional programming. In this class, I will explain you how to handle exceptions. The attempt to divide by 0 will cause the Python runtime system to raise zero division error exception. This is an example of exception. Whenever you attempt to divide a number by 0, it will be in a continuous loop. So if the denominator is 0, then by means of repetitive subtraction, division will be performed, and that division will always be in a loop. It is continuously doing subtraction as each time you will get 0 only. So this is zero division error exception. And let us see this one with an example program, exception1.py, and how to handle zero division error. Let me open Anaconda. This is my program. I have exception1.py is the program. I have two variables. Both are integer variables. First one is successes and second one is failures. I want to determine success failure ratio, SFR. I call it as SFR. So SFR equals successes divided by failures. Finally, you print the success divided by failure ratio is SFR. Print now here. Now, instead of 54, instead of 0 here, I put say 6 and I run this program. You see here, the success by failure ratio is 9. Now here, so now here is just written, a print statement is just written so that after successful printing of this one, SFR, it will come to that stage. Now, to the failures, I will give 0 as input. Now, it is a case of divide by 0 error. I will run this program again. No, it is not producing the result. It says 0 division error, division by 0. Okay, something awkward happens. It is not producing the result, and this is to be handled properly. It should not be left like this. Whenever there is an attempt to divide a number by 0, it must be handled. For that purpose, we are using a try except. I told about try except in network programming. You can recall, while searching a file at the server end, if the file is not present, then it must be handled by using try except. So I have already written program here. After the initial 5 lines of the program, I have written the actual program to handle the exception. Now just I uncomment them. And then I will explain this program. Okay, I have removed these 3 and again I'm using them at the end after the except. So as in the earlier case, here also I have two variables, successes and failures, 54, and I have taken in place of 0 as in the earlier case I have taken 6. See here how to handle the exception. To handle exception, I have to use a try except. So in the try, you have to do the computation, whatever program you have written to find out the success failure ratio. SFR equals successes divided by failures. Print success by failure ratio is SFR, same as the earlier case. Now, if there is any exception here, That is, there is a possibility of zero division error that must be written after except. Remember here, this zero division error is a built-in error of Python. I have to write like this only. Z-E-R-O. Z starts with a capital letter, then D-I-V-I-S-I-O-N-D with a capital, error with capital. It is zero division error, not division zero error. Same syntax is to be used here also. Then only this exception will be handled. Otherwise, exception won't be handled. It throws an error. So after performing division, if there is an exception, directly it will come here. It will not print the success by failure ratio. Instead, it comes here, no failures. Hence, SFR is undefined. Okay, so no failures means number of failures. If it is equal to 0, it is not possible to find out success by failure ratio. That is why since there are no failures, SFR is undefined. Then finally it will come now here. So in the earlier version of the program that we have written, if failures equal to 0, it will not come to now here. Only if failures is a non-zero number, then it will come to now here after computing success by failure ratio. Whereas here, after using this try except, it will print now here for both cases, whether the failures equal to 0 or non-zero. Let me clear the console and I will run this program. See the result. The success by failure ratio is 9.0, 54 by 6, and it prints now here. Now I will change the number of failures. I will make it as 0. Now you see, it should handle, my program should handle this case. Again I run this program. See the difference between the earlier version and this version. Now it says no failures, hence SFR is undefined. That means a division 0 error has occurred, hence it will come to the except block. This is my except block. In the except block I have a print statement, no failures, hence SFR is undefined. Afterwards it will print the last statement, now here. So this is how you have to write a program in a very professional way. In the earlier case, we have not handled the exception, whereas in the second case, we have handled the exception zero division error in a professional way by using try except block. Let me continue. I will take you back. Shift F5. Another case. Now we have tested for zero division error and I have used a try exception block there. Another type of exception is value error. What is a value error? If the user enters a wrong data type, that means string in place of integer, float in place of integer, integer in place of a character, then the Python runtime system will raise value error exception. So if the intended data type is not entered, then it will throw a value error. So there are two programs here, exception2.py and exception3.py. Let us see each one after the other. I will now open exception2.py. Let us see what is written here. So I have taken I have written a while loop. It is always true so that the system will enter inside the loop. In the while loop, I have used this try except for value error. So ask the user to enter an integer, input an integer. You see here, if the user is not entered an integer, then it has to throw an error, value error. And this program has a specific purpose. The entered integer's square is to be computed. In the print statement itself, I have written that statement: print the square of the number you enter is val to the power of 2. So val is the integer value that the user has entered. It is raised to the power of 2 so that the square will be printed. Afterwards, it will break here itself. So within the try block, it will break. It will not enter the except. In case at the time of enter an integer statement, if I input a non-integer, then there is a value error. Suddenly it will catch a value error. Instead of executing a try block, it will come to the except block. Since it is a value error, it prints the statement val. The value that I have entered is not an integer. Okay, so let me run this program. Prior to running the program, I will clear the console. Run the program. So enter an integer. I enter 6. The square of the number you entered is 36. Again, I run the program. This time, instead of entering an integer, I will enter a floating point number, say 6.4. Immediately it says, because of value error, 6.4 is not an integer. In the same way, if I run again, now if I enter say x, it says x is not an integer. So I have to enter the integer. If there is no integer, it will go to the except block and types and prints the error message. The same program is written here as exception 3. So this is in the only difference between the earlier program exception 2 and exception 3 is in exception 3 I am handling the same value error by using a function called read value. So this is a specific case of a polymorphic function, a polymorphic function. In exception 3.py, the function readval is polymorphic, that is, it works for arguments of different types. Let us see what it is. You see here, I have read value which takes three different arguments. The first one is a data type, and second one is a request message, and third one is the error message. Request message is for the user to enter a value, and error message, if there is an error, that error message will be displayed in the except block. So here, how this one is polymorphic. You see here, the value type, so that I am sending from here, which could be an integer or a character or a float, etc. So it will take any type of data type as a parameter. That is why it is called polymorphic. Let me clear the console and run the program. Control L. Okay, so this program is also it is similar to the earlier one as far as functionality is concerned. So enter an integer is not an integer. So both is passed as parameter here. There is a while loop here. If the value you have inputted, if it is not an integer, then it will throw an error message. Error message is again passed as a parameter here. So error message is not an integer, and request message is enter an integer. Now I run this program. Enter an integer. I enter 4. The square of the number you entered is 16. It will also produce a square. You see here, value to the power of 2. Next, again I will run. This time I will input a float. I input say 4.6. You see here 4.6 is not an integer. Again it says you enter an integer. So this time instead of integer I enter say D, a character. So So it says D is not an integer, enter an integer. Okay, thank you.